This is section 4, rhombi and squares. They have some very similar properties, so they are together in one section. So looking first at rhombi. They have the same properties as parallelograms, so just like rectangles did, these 4 properties are the same with rhombi as they are with parallelograms and rectangles. The 2 additional properties with rectangles, however, do not apply to rhombi. These 5 initial properties plus 3 others, one of which being that all 4 sides are congruent. All 4 sides are congruent. So I kind of drew my little rhombus over here. So that means all 4 sides of the shape are congruent. Also, their diagonals are perpendicular. So remember, that means that they form 90-degree angles all the way around. Their diagonals do. And then last, their diagonals bisect opposite angles. They bisect opposite angles. Oops. So what that means is, remember, when a line bisects an angle, it splits it into 2 equal parts. So those 2 are congruent. These 2 are congruent. And that makes these 2 congruent to these ones up here, because opposite angles are congruent. Therefore, all of those are congruent to each other. Okay, so let's look at some rhombi. Try and find some of these sides. Okay, so we know JK is 12 and JN is 7. Alright, so we want to find JM. So JM is right here. Oh, that's a side, which is congruent. I mean, all 4 sides are congruent. So that means all 4 of these are 12. Making JM 12. JL is this one all the way across here. Is this diagonal? Now remember, diagonals bisect each other. So that means that each of these pieces, JN and NL, is 7. Therefore, JL is 7 plus 7, so it's 14. Then we want to find MN. So this one right here. Okay, this one's similar to one of those things you have to do with rectangles. So notice how this triangle right here is a right triangle, because when the diagonals bisect each other, they are perpendicular. So I make a right triangle here. Well, I know that one of the legs is 7, the hypotenuse is 12, so I can use my Pythagorean theorem to find MN. So we'll set the MN equal to x. So x squared plus 7 squared equals 12 squared. So x squared plus 49 equals 144. X squared equals 95. So then x equals 9.7. So that makes MN 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. 9.7. So, since MN is 9.7, my last one I need to find is MK. So that is this whole thing. Since this one's 9.7, that means this one's also 9.7, and K is also 9.7. Add them together and you're going to get MK, which is 19.4. So that is learning about sides and lengths of diagonals in rhombi. Let me see if there's any of these other ones I want to do here. I don't think so. Nah. I think we'll be good. Okay. Well, we can look at number 4. Okay, so angles with rhombi are pretty simple for the most part. So remember, diagonals bisect opposite angles. Also remember, opposite angles are congruent. So when it bisects these two angles that are congruent, it splits it into two equal pieces. Those two equal pieces then are congruent. So that makes those two congruent all to those two there. It also makes these two congruent to these two. So all of the yellow angles are congruent, all of the gray angles are congruent. And then the angles in the middle, also like this one here, remember those are all 90 degrees because it's a rhombus. And then also remember still consecutive angles add up to 180. So if I want to find, well, I can automatically do 3, 4, and 5 just because I know this one right here is 38. And those are all congruent. So angle 3 is 38 degrees. Angle 4 is 38 degrees. And angle 5 is 38 degrees. Okay. We also know angle 8 because it's a 90-degree angle. It's a right angle. Okay. Then that just leaves us left to find 1, 2, 5, and 6. So that's where I'm going to go back to. Remember that consecutive angles add up to 180. So if I find this whole thing, let me do it in a different color. This whole angle here, it is 76, I believe. 76 degrees. If it is 76 degrees, then that means this whole angle up here is 180 minus 76 degrees. So it's 104 degrees. Since the diagonals bisect, that splits this angle in half to find angles 1 and 2. So 104 divided by 2 makes both of these 52 degrees, which then also makes these two 52 degrees. So measure of angle 1 is 52 degrees, angle 2 is 52 degrees, angle 6 is 52, and angle 7 is 52. So really, you only have a few different angle measures that apply to multiple angles. So you could go ahead and do 2 and 3 and 5. And I'm going to move on to the back. Properties of squares. Properties of squares are kind of neat because they combine all properties that we've learned. All properties of parallelograms, rectangles, and rhombi. So all of these that are properties of parallelograms. These are all properties of rectangles, and these are all properties of rhombi. So looking at number 6, if ABCD is a square and AD equals 11, we need to find each missing value. So since these, because it's a square, these come together to form 90-degree angles, and all of these sides are 11. I'll leave it at that for right now. Okay, to find BC, that's congruent to AD, so that one's easy. It's 11. AC, we can do like we did with rectangles. So since all those in the middle are 90-degree angles, also remember all of these are 90-degree angles. So I can split this into a right triangle where AC is the hypotenuse, and use my Pythagorean theorem to solve. So 11 squared plus 11 squared equals x squared. So 121 plus 121 equals x squared. So 242 equals x squared. So x equals 15.6. So that means AC is 15.6. And it wants us to find BD. Okay, on squares, remember up on when we have rectangles, all the diagonals are congruent. So since AC is a diagonal and we already found it, BD is a diagonal, we can find it as well because they're congruent. So it is also 15.6. Then EC, which is this one here, EC, remember diagonals bisect each other, so that cuts AC in half to get EC, so EC is equal to half of 15.6, which is 7.8. And then angles on squares are pretty easy. So all of these are 90-degree angles. And then all of these are 90-degree angles, just like on a rectangle. But with squares, it's really nice because they have the same property as a rhombi, so the diagonals bisect those opposite angles. So that means it cuts this one in half, this one in half, this one in half, and this one in half. Because they're all 90, cutting them in half is going to be 45 degrees on each one. And so on. So that's pretty much all the angles on the square. So the measure of angle DAB, that one's 90. The measure of angle AEB, that's this one right here. That one is also 90. Because the diagonals are perpendicular. Angle CBD, so this one right here. That one is 45 because it's 90 cut in half. And angle BAC, same thing, 45. So the only possible angles you can have in a square is 90 or 45. That's what makes angles of squares pretty easy, I think. So that's pretty much it. Go ahead and finish 7, and then 8, 9, 10, and 11. Throw some algebra in there. So that, I think, will be all for rhombi and squares. So mark the ones you have questions on. Come to class with your notes done.